Swayam Prabha. Digital India. Educated India.
In today's lecture, we are going to look at the developments in the 1970s in the area of social studies of science. As I said, after we reviewed Marx's theory of science, Marx's theory in fact inspired several post-Kuhnian approaches in the 1970s in STS studies. One of them is interest model of Barry Bernays and constructionist approach of Karina or Satina, to mention a few. Now we will focus on the approaches in science, technology, society studies since the 1970s, especially after Kuhn's influential work. Firstly, let us examine the overarching vision of these approaches, their theoretical and methodological orientations. Post-Kuhnian approaches to the study of science, technology, societies interface. Post-Kuhnian sociology of scientific knowledge has moved from the position that all knowledge except scientific knowledge is socially, culturally conditioned, to the position that all knowledge, including the scientific knowledge, is socially and culturally conditioned. Bloor argues that actually scientific knowledge also should be seen as socially, culturally conditioned. In other words, post-Kuhnian sociology of scientific knowledge opened up the possibility of examining the content of science in sociological terms. For example, the values that guide the work of a scientist, the models used, and explanations advanced or amenable to sociological analysis. Broadly, these approaches included under the rubric of sociology of scientific knowledge. The vision is to bring science fully within the scope of the sociology of knowledge. Knowledge to be related to the context in which it is produced, and that is how you bring this scientific knowledge within the ambit of sociology of knowledge. In contrast to Mannheim's view that exempts scientific knowledge from social causation, the SSK or sociology of scientific knowledge argues that all knowledge, including scientific knowledge, is socially caused. The SSK recognizes that the divide between the internal world of science and the external world is permeable, and there is a two-way traffic between the two worlds. Second, there is also a shift from theoretical studies to empirical studies. Science is seen as a practice. It is moved from, at least we see the movement from science as knowledge to science as practice. Thirdly, the aim of these relativist approaches is academic and also humanistic. Fourth, rational and irrational beliefs have to be explained in sociological terms, unlike the earlier view that as science is rational and universal, it does not have to be accounted for in sociological terms. Only irrational beliefs need sociological explanation. So let me also say that the sociology of scientific knowledge is based on epistemic relativism. Epistemic relativism asserts that knowledge is rooted in particular time and culture, plurality of conceptualization of natural phenomena at different points in time and across cultures. That means there are more than one way of conceptualizing natural phenomena, and this has been done in different civilizations and different cultures. This is, the credit must go to Thomas Kuhn, who recognizes that the scientific knowledge should be located or related to its historical context. In this sense, this opens up the possibility of looking at the knowledge systems that were produced by many other civilizations like India, China. For example, in India we have in ancient time very well developed system of medicine that is called Ayurveda. Ayurveda as a theory and also therapeutics based related to the theory, and it is still being used in our country to cure various kinds of ailments. Similarly, Chinese medicine is very important. It also has evolved over time, and it also has is based on certain kinds of theories or properties of substances that is extracted from nature. Theory of underdetermination is another principle which allows us to relate our data to more than one theory. Theory of underdetermination means that there is no one unique theory to which a set of data can be related. It can be related to more than one theory. So epistemic relativism is different from judgmental relativism, according to which all forms of knowledge are valid. In the sense, the judgmental relativism sometimes is based on ideologies, whereas epistemic relativism is based on actually conceptualizing the phenomena and understanding them by using a method. There are, as I said, the sociology of scientific knowledge led to several approaches, and persons like Pickering developed microsocial approaches. Barry Bonds was one of the important influential sociologists who really developed a macrosocial approach to the study of science. Macrosocial approach is based on the commitment to relate knowledge to the context, right? What is it that in the context to which knowledge needs to be related? The macrosocial approach developed in the 1970s by Barry Bonds, David Bloor, Stephen Chapin at Edinburgh. The macrosocial approach attempted to trace causal connections between interests of relevant social groups and the content of scientific knowledge sustained by these groups. What it means is, knowledge is generated, or the motivation to generate knowledge is based on interests of various kinds. It can be economic interest, it can be professional interest, it can be interest relating to culture, interest relating to politics, and so on. So one can see that the attempt here is to relate knowledge generated in a particular context to the interests that operate in that context and the interests of various groups, relevant social groups. The second approach is microsocial approach. I mentioned earlier Harry Pickering, it is not Pickering, it is Harry Collins. Microsocial approach, Harry Collins, working at Bath, pioneered more microsocial approach at Bath. Collins, on the basis of his studies of scientific controversies, showed that contingent negotiations play an important role in producing consensual knowledge. Going back to the macro social approach, let me say what kind of interests, how interest can influence the way we generate knowledge. For example, if my interest is to find out what are the important timber yielding plants in Himalayan forests, I classify Himalayan forests into timber yielding plants and non-timber yielding plants, right. So this is how interests play a role in trying to generate knowledge about our surroundings. And going back to this microsocial approach, Harry Collins says that the consensus on knowledge is based on negotiations rather than a pre-given technical impersonal kind of criteria. It means the knowledge production and its acceptance and its communication is closely related to the social factors, both internal to science and also external to science. As I said, Barry Bonds, one of the influential figures who really started a macro social approach to understand science and relate science to its context. According to Barry Bonds, there is diversity of beliefs about nature. He observes that scientific beliefs about nature are accepted beliefs and not correct beliefs. He observes that the conventional view of science that characterize knowledge as universal, atemporal, objective and invariant. I mentioned just now that that which is universal and rational does not require sociological explanation, but only irrational beliefs have to be explained sociologically. Barry Burns argues that we should analyze as to what extent both rational beliefs and irrational beliefs are socially caused. He says that notions like simplicity, sometimes attached to new scientific theories, cannot be given an objective definition. Simple in terms of what? Scientific explanation is simple only in terms of certain viewpoints. Similar is the case with terms like efficacy, elegance. These terms do not have any objective definition. These are defined differently in different contexts, and so there is nothing like an objective definition of these notions like simplicity, efficacy, elegance, which sometimes scientists say has attracted them to a particular new theory. Barry Burns also argues that the culture of natural science is a subculture of the wider culture, and over time the culture gets differentiated from wider culture in terms of the concepts and their meanings and certain ways of looking at the phenomena. He suggests that the notion of accepted fact has a social element in that it is a collectively produced statement. All facts have this dimension of or attribute of collective production, and something becomes a fact if a group of people say what they observed in a particular context about a particular phenomenon becomes a fact. It's rather than one person trying to say that what he found was a fact. It has to be verified. Yeah, I just now mentioned Barry Burns argues that the notions of simplicity, elegance and efficacy do not have objective definitions, and they are context dependent definitions. Then Barry Burns asks this question: can we accord special status to scientific culture? In what sense these beliefs, scientific beliefs occupy, or scientific culture occupies a special status? He argues that scientific culture is part of the wider culture but gets differentiated from the wider culture with its own language and concepts. He also says that theories are metaphors and theory changes are metaphorical redescriptions. The metaphors are sometimes drawn from wider culture. A metaphor involves comparing the uncomparable or comparing objects which look similar. For example, saying that a person roars like a lion means that it's only to describe his voice rather than trying to say that he is a lion. Similarly, Kekule's description of Benjamin as a snake biting its own tail is a metaphor. Benjamin is not actually a snake. As I said, Barry Burns strongly argues that our interests and goals direct our knowledge acquisition, and he gives examples of from various cultures. For example, every culture teaches its members concepts and application of concepts, and application of concepts leads to classification of objects. For example, classification of flora and fauna in the forests. So that is, every culture has its own system of concepts and also application of this context to understand the surroundings. As I mentioned just now, one can classify a forest on the basis of medicinal plants, timber yielding plants and other commercial uses of the forest produce. For example, the Amazon forest may be classified into medicinal plants, diversity in snake population or some other purpose depending on the interests of the investigator. A multinational corporation may be interested in exploring Amazon forest for medicinal plants so that the corporation may obtain patent right after identifying useful or active molecule in the plant or animal species. Now, various interests govern our quest for knowledge acquisition. It is not all the time that curiosity drives knowledge acquisition, right? That is one of the earlier views of science, that it is curiosity which drives people to understand nature. And we have seen in the case of Marx, for example, it is the mode of production which shapes what knowledge is produced and how it is used. Of course, curiosity is an important element, and curiosity by itself may not lead a person to acquire knowledge, and sometimes we also discover things by serendipity. Serendipity refers to the finding of a object or finding of a discovery of a phenomenon when we are looking for some other phenomenon. That is, we stumble upon a new phenomenon which we did not anticipate because we are looking for some other phenomenon. This is called serendipity. The next influential person in the 1970s to shape the agenda of the sociology of scientific knowledge, as I said, is David Bloor. Unlike Mannheim, who argued that all knowledge except scientific knowledge is socially conditioned, Bloor argued that all knowledge including scientific knowledge is socially caused. The strong program of David Bloor, a 1976 book, Science and Social Imagery, he postulates 4 tenets of the strong program which sociology of scientific knowledge has to adhere to. 1. Causal. It is concerned with the conditions which bring about a belief or states of knowledge, social and other types of causes. What he is saying is, I just now mentioned more than once, that he says both rational beliefs and irrational beliefs have to be causally explained. One must find causes of why certain rational beliefs come into existence at a particular point in time and why certain irrational beliefs come into existence at a particular point in time. Both require causal explanation. Impartiality. Impartial with respect to the truth or falsity, rationality and irrationality, success or failure. Both sides of these dichotomies will require explanation. That is, impartiality means can't all the time explain why a particular thing became successful without explaining why certain other things became failures. As I said, rationality, irrationality also have to be, one has to be impartial towards these beliefs. Both sides of these dichotomies will require explanation. Third principle is symmetry. It would be symmetrical in its style of explanation. The same types of causes would explain true and false beliefs. See, for example, symmetry means same kind of explanation must tell us why a particular bridge constructed on a river stands and why a particular bridge collapses, right. So, it is in this sense one should be able to explain using the principle of symmetry. Reflexivity means, in principle, its patterns of explanation would have to be applicable to sociology itself. Otherwise, sociology would be a standing refutation of its own theories. Reflexivity means you all the time reflect on what you are saying, what you are analyzing, whether it makes sense or not, right. So, it cannot be that one arrives at the truth or one arrives at an explanation without engaging reflexively in trying to look at alternatives, alternative explanations. Now, this is an important intervention by Bloor in trying to say that science also has to be brought under the scrutiny of sociological scrutiny by employing these 4 principles. The next approach that we are going to look at is constructionist approach. So, as I said, interest models and constructionist models share certain things in common. Karina Orsetina did an empirical sociological work in laboratory. She found that there is a life world of scientists and the reasoning they employ is not rationality in a normative sense. She adopts a constructionist approach in contrast to the objectivist account of science to understand knowledge, how knowledge is produced at the site of production, that is laboratory. She says, and I quote, to the objectivist, the world is composed of facts and the goals of knowledge is to provide a literal account of what the world is like. Empirical laws and theoretical propositions of science are designed to provide those literal descriptions. In the sense, according to objectivist account, there are certain facts lying outside, they are objective, and our job is to find out, discover these objective facts and describe them, right? Observe these objective facts and describe them. It's also based on a positivist belief about the world, that the world consists of objective facts, and the job of a scientist is to provide descriptions of these facts. The basic thesis that Karina Cetina proposes in her work, and I quote, "The products of science are contextually specific constructions which bear the mark of the situational contingency and analysis, infrastructure of the process by which they are generated, and which cannot be adequately understood without an analysis of the construction." That is, she also relates the process of production of knowledge to a set of interests and the local contingencies, the local factors that obtain in a particular context at a particular point in time. This means that what happens in the construction is relevant to the products that are produced. That is, the construction of knowledge is a process, is relevant to the products that are produced. That is, both the products and the processes are related, whereas earlier people said, I mean some of the philosophers said that these are two separate things. One does not have to look at the process, but one has to only look at the product. In contrast to the objectivist account, Karina Cetina argues that the facts are fabricated in the laboratory. The fabrication involves decisions regarding selections, and I quote, "The process of fabrication involves chains of decisions and negotiations through which their outcomes are derived. Phrased differently, they require that selections be made. Selections in turn can only be made on the basis of previous selections. They are based on translations into further selections." That is, fabrication involves several decision making, decisions and negotiations, and they also require selections. That is, given several options, which one do you select? Given several ways of carrying out an experiment, which option will you select? Given certain variety of, given certain options to have particular kinds of equipment, which of the equipments are you going to use for your experiment? Which involve decisions on the basis of selections. That is, selections in turn can only be made on the basis of previous selections. That is, if you select one particular kind of, decide on one particular kind of experiment, then you also decide what kind of equipment that is needed to carry out this experiment, and what kind of arrangements are required for carrying out this experiment. Now, in the sense that if you decide on one particular way of doing things, it leads to the subsequent selections that have to be made in terms of what materials you are going to use, what equipment you are going to use, and so on. So, Karina Cetina says the laboratory is also a context of discovery and also partly context of validation. Karl Popper, a famous philosopher who advocated hypothetical deductive method and the rationalist philosophy of science, argued that the context of discovery is a private domain and the context of justification is a public activity. We are not interested whether the scientist got the idea in a dream or while walking, but we are interested in how he or she justifies the knowledge claim, a discovery or a new theory. Justification is always a public activity. Justification involves testing, justification involves how one arrived at this particular claim, which has to be subjected to public scrutiny. Cetina argues that the laboratory is the site of discovery and also partly the site of validation or justification. As scientists always evaluate their claims by assuming the role of evaluators, that is, the producers of knowledge and the evaluators are members of the same community. That is, when I make a statement, I always see whether it makes sense or not. Well, how the other colleagues are going to evaluate my statement, my knowledge claim. I always do this by putting myself in the position of the others. This is also a Weberian technique of trying to understand the other by putting oneself in the other's position. The same thing happens here. The scientist, whenever he or she makes a statement about a particular knowledge claim, he or she always will see how others will look at this statement, how the others will evaluate this statement. So in that sense, the laboratory itself becomes partly the context of validation or justification. Karen or Satin also says that laboratory studies, which are micro level, micro social studies of science, according to Harry Collins, micro social studies of science involve working with scientists, interacting with scientists, rather than looking at the products, looking at the theories they produce, looking at the kind of models they produce. She says sensitive methodology requires methodological engagement rather than detachment, contact rather than distance, interest rather than disinterest, methodological intersubjectivity rather than neutrality. The earlier studies, perhaps the positivists would argue that one has to really go by what scientists have said already, produced already, rather than talking to them. You analyze the products, analyze and say what they mean actually. Whereas here we are saying, Karin or Satin are saying, a sociologist must go to the laboratory, interact with the scientists, and that means one should not maintain a distance from scientists, but one should contact the scientists. One should not be disinterested, but show interest in trying to find out what scientists are doing, and so on. So intersubjectivity means that when two individuals interact, really both of them enter into a dialogue and try to understand each other. Sensitive sociology is like participant observation that is used in anthropology. North Satina study also indicates that scientists in the laboratory or scientific action in the laboratory does not correspond to normative descriptions of scientific knowledge as the philosophers do. Scientists typically employ several types of reasoning in their actions associated with knowledge production. Practical reasoning, according to what can be done given the resources rather than waiting for the resources that one needs for research. Indexical reasoning, same action will have different meanings in different contexts, or different actions will have same meaning in different contexts. Analogical reasoning, comparing the uncomparable to understand the observation that is new, that's made, which is new. Socially situated reasoning, how related to how one can negotiate with the requirements of the organization that employs scientists, career advancement, in-house support for research, funding agencies and so on. That is, scientists also interact with the outside world, trans-epistemic arena, interacting with the funding agencies, suppliers of equipment, etc. And there is also literary reasoning when the scientist transforms his work in the form of a research paper, and that requires literary reasoning. As I said, what does one mean by a scientist as a practical reasoner? To understand how scientists produce, to understand how scientists produce and reproduce their knowledge, the researcher has to interact with the scientists in their laboratory. Karen or Satin observes, and I quote, "It is not really the scientific action that we should confront, but the savage meaning of ongoing events for and by the scientists. To get at this meaning, we must really talk with the scientists." The job of a researcher is actually to understand the savage meaning that people attach to events that go on in the laboratory. What do these events mean for the scientists? What do these events generated by the scientists mean for others? Okay, this is an important contribution, methodological contribution that Karen or Satina's work makes. The second, cognitive and practical reasoner. I said the content of practical reasoning involves let's look at the content of practical reasoning. SSK, as mentioned above, insists that the content of science also should be analyzed so that one gains an understanding of the internal processes and strategies. The distinction between cognitive and social has to be dissolved, as what is cognitive is also socially arrived at. Norsetina, who studied the process of production of knowledge by talking to scientists involved in plant protein research in the laboratory supported by the government in the US, which employed 330 scientists and engineers. Practical reasoning involves seizing the opportunities to do research with the resources that are available instead of waiting for the resources that one needs to pursue a line of research that one likes to pursue. Practical reasoning enables scientists to do research and publish quickly with the resources that are available. Then the scientist has indexical reasoning. Indexicality means that a sign may have different meanings in different contexts, and different signs may have the same meaning in different contexts. For example, there are in different cultures there are various ways of greeting people, but the meaning of these gestures is same, that they are trying to greet each other. That is, different signs have the same meaning. Sometimes a particular action, particular gesture will have different meanings in different contexts, right? For example, the meaning that people attach to the color black may be different in different contexts, right? Norsetina uses the term indexicality to refer to situational contingency and contextual location of scientific action. Indexicality has an implied opportunism which shows up as a mode of operation comparable to that of the tinkerer. The tinkerers are opportunists. And I quote, this is a quotation of a scientist which Norsetina quotes, and I quote that, a tinkerer does not want or does not know what he is going to produce, but uses whatever he finds around him. The tinkerer gives his material unexpected functions to produce a new object. Then the third is scientist as an analogical reasoner is based on a logic of resemblance and the notion of similarity. Analogies are part of the repertoire of all languages. The similarity is based on analogous features. For example, one of the scientists in Norsetina's study mentioned that a particular protein looked like sand. So, a protein is not sand. Protein is, at least in this particular study, she was working on plant proteins. Obviously, the plant protein is an organic substance, whereas sand is an inorganic substance. So, you are trying to compare the two which are not comparable to basically understand the one that you really produced. By comparing sand with a protein, you understand the protein better. That is the purpose of analogies. The scientists are socially situated reasoners. The laboratory production which are based on situational contingencies emerge as social contingencies. Social contingencies connect the scientist to the scientific community, the scientific organization to which the scientist is affiliated, and the expectations of the organization, the funding agencies, and so on. In this sense, the scientists get connected to trans-epistemic arenas. The last, scientist as a literary reasoner, scientific knowledge that is produced in the laboratory under the influence of situational contingencies or communicated to journals as a form of formal report, formal communication, so that it is available to a peer group in that field, and this paper has to be prepared according to formal format that a journal has, and while writing a scientific paper, all the contingencies that influence the work, all the situational factors that influence the work are not really reported in the paper, in the research paper or the manuscript. So, it is a more formally stated statements about what the kind of work that has been done, what is the outcome of the work, what is the methodology that was used, and so on. A typical research paper will have the following sections. There is an introduction, there is a review of literature, there is objectives of the study, research questions, and then experiment methodology used to answer the research questions, and there is a section on results and discussion and conclusions. Now all that has been produced in the laboratory is put into this kind of a format and reported to the peer groups. The next important contribution to these micro social studies comes from Bruno Latour, who wrote a book on science in action, and in which he formulates the rules of method to understand the process of production of science. He says science has two phases. The genus, science is like a genus which has two phases, and one of the phases is a ready-made science. The second is science in making, right. He said if you really want to understand science, we should really understand the science in making. So the first rule is we study science in action and not ready-made science or technology. To do so, we either arrive before the facts and missions or black boxed, or we follow the controversies that reopen them. In the sense that if you really want to understand how scientific knowledge is produced, one has to really understand right from the beginning of this production of knowledge, rather than trying to look at science as a finished product. As I said, the first phase, one phase of science is that is shown as a finished product. The other phase is the kind of thing that I said, science in making. Rule 2 is to determine the objectivity or subjectivity of a claim, we do not look for their intrinsic qualities, but all transformations they undergo later in the hands of the others. That is, whether a particular knowledge claim is subjective or objective, we cannot decide intrinsically on the basis of the intrinsic qualities, but what transformations they undergo later in the hands of others. That is, one has to watch how this knowledge is being transformed by others. Rule 3, science, since the settlement of a controversy is the cause of nature's representation, not its consequence, we can never use the consequence, that is nature, to explain how and why a controversy has been settled. And he says that, so what it means is the settlement of a controversy, scientific controversy, is the cause of nature's representation. That is how and why nature is represented, not its consequence. We can never use consequence, that is nature, to explain how and why a controversy has been settled. That is, you can't use the consequences of what has been done to understand the how and why a particular controversy has been has arisen and how it was settled. Rule 4, since the settlement of the controversy is the cause of society's stability, we cannot use society to explain how and why a controversy has been settled. We should consider symmetrically the efforts to enroll human and non-human resources. See, because a scientific controversy, when it is solved, when it is settled, it causes stability in the society, but we cannot use society to explain how and why a controversy has been settled. That is, society's stability is the dependent variable and the controversy is the independent variable, as it were, and we should really look at, we cannot use society to explain how and why a controversy has been settled. We should consider symmetrically the efforts to enroll human and non-human resources. Rule 5, we have to be undecided as to the various actors we follow as to what technoscience is made of. Every time an inside or outside divide is built, we should study the two sides simultaneously and make the list, no matter how long and heterogeneous, of those who do the work. In this sense, how does one decide what is technoscience? See, Latour says technoscience is much more than science and technology. It involves networks, it involves associations of people in the production of knowledge, and we have to be undecided as to as the various factors we follow as to what technoscience is made of. Every time an inside outside divide is built, we should study the two sides simultaneously and make the list, no matter how long and heterogeneous, of those who do the work. That is, the listing helps us to identify networks, identify associations of people. Rule 6 is, confronted with the accusations of irrationality, we neither arrive at what rule of logic has been broken, nor at what structure of the society could explain the distortion, but to the angle and direction of the observer's displacement and the length of the network thus being built. See, we can't really explain why the accusation of irrationality, or to put it the other way, confronted with the accusation of irrationality, we neither arrive at what rule of logic has been broken, nor at what structure of the society could explain the distortion. What it means is, earlier we were discussing that the earlier philosopher said, because scientific knowledge is universal rational, it does not require sociological explanation, only irrational beliefs require sociological explanation. What he is saying is, irrational beliefs is somehow arises because of by breaking a logic. That means, and also what kind of structures of society explain these irrational beliefs. What he is saying is, we will not judge, we will not arrive at what rule of logic has been broken or what structure of society would explain distortion, but to the angle and direction of the observer's displacement and the length of the network thus being built. Rule 7, he says, before attributing any special quality to the mind or method of people, let us examine first the many ways through which inscriptions are gathered, combined, tied together and sent back. Only if there is something that remains unexplained, once the networks have been studied, shall we start to speak of cognitive factors. Knowledge involves not only equipment, not only certain kinds of understanding of the phenomena, but also various networks, various associations. He also has evolved some principles which are related to the rules. First principle is, the fate of facts and missions is in letter users' hands. Their qualities are thus a consequence, not a cause of collective action. That is, the qualities of a particular mission, particular equipment, their qualities are thus a consequence, not a cause of collective action. Right? The qualities arise after the missions are produced and they produce some consequences. Second principle is, scientists and engineers speak in the name of few allies that have shaped and enrolled. Representatives among other representatives, they add these unexpected resources to tip the balance of force in their favor. Third principle is, we are never confronted with science, technology and society, but with a gamut of weaker and stronger associations. Thus, understanding what facts and missions are is the same task as understanding who the people are. That is, there is a close link between the group of people who are producing, which is producing this knowledge, and who these people are. The fourth principle is, the more science and technology have an esoteric content, the further they extend outside. Thus, science and technology is only a subset of technoscience. In the sense, technoscience includes science and technology plus the networks and associations that are involved in production of these knowledge. Fifth principle is irrationality is always an accusation made of someone building a network or over someone else who stands in the way. Thus, there is no great divide between minds, but only shorter and longer networks. Harder facts are not the rule but exception, since they are needed only in very few cases to displace others on a large scale out of their usual ways. See, normally what he is saying is the principle states irrationality is always an accusation made by someone building a network or someone else who stands in the way. That is, each one tries to accuse the other as being irrational because that person is standing in the way of the network that one wants to build. So, one should really look at how the dynamics of this building of networks, building of associations operate, and it is important to understand the dynamics. The sixth principle is history of technoscience is in large part the history of resources scattered along the networks to accelerate the mobility, faithfulness, combination and cohesion of traces that make action at a distance possible. History of technoscience means how technoscience evolved is in large part a history of resources scattered along the networks to accelerate the mobility. How, see, basically technoscience means how the resources are scattered and how they are mobilized for producing certain kinds of knowledge and also certain kind of artifacts. So, Latour argues that science is presented as a product, to conclude, Latour argues that science is presented as a product, a ready-made product. The challenge for social scientists is to capture the process of producing scientific results or science in making. He argues that our entry into science and technology will be through the back door of science in the making, not through the more grandiose entrance of ready-made science. Okay. To conclude, that Bruno Latour also lays down certain methodological principles to understand science, the process of scientific knowledge production, and it is very important to follow the process of production, right. I end this lecture. Thank you very much.